All right, well, I'll get rolling with a quick intro. Hello, everyone. My name is Becky Feldman Edwards from USGB CLA, and we are so happy to have you joining us for Decarb 101, the first in a three-part series from our Building Decarb Committee. I just wanted to give you a little bit of a rundown of what USGB CLA is up to today before we get started. We have a lot of great content coming at you in February and March. And so please check us out with whatever you are interested in. We have a great thought leadership event coming up this Thursday, tomorrow, actually. So check that out. And you can find all of this content and more on our talent portal. It's the best place to check for our content, both upcoming and recorded content, green jobs posting, local employers, all of our trainings, everything good can be found on the talent portal of the USGB CLA website. And there's a lot of other great ways that you can get involved with USGB CLA, namely our committees. So this is a presentation of one of our fabulous committees, the Building Decarb Committee, but we focus on a variety of topics from advocacy to emerging professionals. So check these out if you're looking for a first step to get involved with our chapter. And there are a lot of other great programs that we do. The Green Schools is not only a committee, but a program. And we're actually in full swing with a new virtual initiative where we are doing sustainability education virtually to elementary and middle schools. And there is awesome opportunities there. And we also are just kicking off a new cohort for our Net Zero Accelerator where we are piloting new technologies in the sustainability world. So that's another great one to check out. And another fabulous thing that we're doing right now is the Healthy Building Alliance. And we rolled out a work from home section of it. Since that's what we're all doing right now, want to maximize our work from home space. So there's a lot of tools to help you do that, both for individuals and companies. And we are a small nonprofit team. So if you like the content we're putting on today or anytime, please consider donating. We have a quick text to donate, so makes it easy and simple. And we hope you'll join us for all the other upcoming programs that we have. And of course, we could not do this without the wonderful companies and individuals that sponsor us to do this work. So we always appreciate you. Thank you for being here, and thank you to those that make this possible. And enough of me. While we jump into this content, I first wanted to introduce Ruby Rose Yepes, who is the co-chair for the Decarb Committee and a senior advisor at SoCal Edison. Thanks for being here, Ruby.
Great. Thank you, Becky. I am so excited to be able to launch our first workshop. As Becky mentioned, my name is Ruby Rose Yepes, and I am the co-chair of the Building Decarb Education Committee, which Carolyn and Patty are both helping to support. And I'm really excited to be launching our first workshop of a series of three focused on carbon. What is it? People are, talking about it all the time. It's the hot topic, and many of us may not even know what we're talking about. So we have with us some very talented and knowledgeable industry peers with us today that are from Arup that are going to give us a rundown on carbon literacy. So whether you are new to the carbon discussion or entrenched in it, they will have some great insight for you. And as Becky said, if you want to volunteer for any of the committees, we're looking for volunteers. So reach out to me or Becky or one of us, and we'll be more than happy to take your time. So Martin and Zara, the stage is yours.
Martin, we can't hear you.
It's only been 12 months. I still haven't learned. Great. Thank you, Becky and Ruby. Great to be here. And so today, I'll start us off, Martin Howe with Arup, before handing over to my colleague Zara Fahim. And Zara and I sit within Arup's Energy and Sustainability Group here in LA. And consult on a broad range of projects that are focused on decarbonizing the built environment and its infrastructure. And as a firm, Arup has really aligned our business to ensure we are seeing sustainable outcomes on our projects. And so, we're happy to be here to spread the word and, open to look for opportunities to collaborate as we really seek to find approaches to decarbonize all of us together, really. We'll spend about 40 minutes on the content, and then we'll have some time for questions at the end. And so, as Ruby mentioned, this is the first of 3 webinars focused on decarbonisation. This particular session is titled Carbon 101 and is really meant to be a foundational session that will cover some key definitions. It will outline some of the policies and other drivers for decarbonisation, as well as touching on some of the enabling approaches and trends that are leading us down the path of decarb. It will also briefly cover the differences between embodied and operational carbon, but we'll be leaving, the remaining 2 sessions to do a deeper dive on those, and those I think are envisioned to happen in March and April. So moving on, into definition. So the first definition, of course, has to be decarbonisation. So decarbonisation is really the reduction or elimination of carbon dioxide from our daily life. Those carbon dioxide emissions might be associated with the energy that we use within our homes or places of work. That might be associated with the manufacture of products we consume. They might be associated with transportation systems. And as noted on the slide, decarbonisation is really the key solution to reducing the impacts of climate change. And obviously reducing the impact of global warming. There's a range of approaches that are used to decarbonize, ranging from using energy in a more efficient way, say in our buildings, to generating energy using renewable resources like the sun or wind. When designing buildings, this also begins to touch on choices made in the selection of materials, perhaps with a focus on materials that are more natural, such as timber, or those with a smaller carbon footprint from the manufacturing process. And then there's also personal lifestyle choices that can help us to decarbonize. So, for example, choosing to carpool to the office, or to take public transportation, or choosing a less carbon intensive diet, like a plant-based diet. And so when we talk about carbon emissions, they're somewhat nebulous, and so it's important to be able to break them down into more defined chunks. And the greenhouse protocol, gas protocol, which provides frameworks to really measure and manage greenhouse gas emissions, came up with the definitions that are shown on the screen. So these are really widely used for measuring and reporting carbon emissions. So here the emissions are broken down into 3 groups, which are each called scopes. So scope 1 covers the emissions from fuel directly burnt on site. So say for a higher education campus, that would typically include natural gas that's used to provide space heating and domestic water heating. And if the campus owns, say, a fleet of vehicles for maintenance that uses fossil fuels, it would also include the emissions from those. Scope 2 covers the emissions from electricity that's produced off-site, typically by a utility company like Edison, but used on the campus. So again, with our higher education example, that would include the electricity associated with lighting the buildings, running fans and other equipment needed for air conditioning and so on. And then scope 3 is by far the largest bundle of emissions and pretty much covers everything else. So again, for our higher ed campus, that might include business travel by employees, say for attending conferences. It might include the emissions associated with outsourced activities, such as maybe food service, and also covering emissions associated with products purchased for use on the campus, as well as things like carbon associated with the construction, renovation of buildings. And so all of these are pretty challenging, but some progress has been made on scope 1 and 2. And we'll touch on some of those, some of the policies that are driving these shortly. Scope 3 is by far the most challenging, but again, we're starting to see policy and voluntary commitments start to creep in as well. And I think it's going to be a big focus over the next few years in the field of decarbonisation. So a few more definitions. that we're hearing a lot about currently. These are all focused on finding ways to decarbonize the built environment. Some of them, and all of them, actually focus on Scope 1 and Scope 2 emissions. So fossil fuels burnt on site plus purchased electricity. The first two definitions are used somewhat interchangeably. That is a zero net carbon building and a carbon neutral building. These would typically be referencing buildings that have implemented pretty high levels of energy efficiency. And on an annual basis, they are cancelling out the amount of carbon emitted through the use of energy by either sequestering an equal amount of carbon or offsetting through on-site renewable energy production, or in some cases procuring off-site renewable energy, or even purchasing carbon credits to wipe out the carbon debt. So again, the accounting is typically completed at the end of the year, and when the annual carbon emissions are fully offset, that building will be a net zero carbon or a carbon neutral building. The third description here, a zero carbon building, is one where no carbon was really emitted from the get-go. So really, this is where we should be heading with our buildings. In this case, it will likely be, again, a highly efficient building with on-site renewable energy and in all likelihood some form of on-site storage that allows it to capture excess renewable energy and use that on-site when needed. That description could also apply to an all-electric building, which is which will reach zero carbon once the electric grid is fully decarbonized, and currently the target for that in California is 2045. And so onto the drivers for decarbonisation, and we've touched on some of these already, but these are really broken down into economic, environmental, and societal. So the three-legged stool, or triple bottom line, as it's also known. Under economic, we have rising energy costs, and the idea that implementing energy efficiency and renewable energy on site will provide some level of insulation against these. I think another way of looking at that would be to say that energy costs will really start to rise when we start seeing the impact of infrastructure upgrades required by things like electrification and grid hardening, but also that we might see other pricing triggers like the carbon pricing start to factor in, similar to the way it has in New York through Local Law 97. Which requires existing building owners to invest in decarbonization strategies or be exposed to fines. So energy efficiency and on-site renewable energy will really provide some protection from these economic triggers. Some of the key drivers under environmental, you can see on the screen, obviously the need to try and avoid significant impacts from climate change, the policy drivers and the ongoing push to increase the resilience of our buildings. Obviously, buildings that are less reliant on offsite infrastructure or that use passive approaches, would typically, or have on-site energy resources, would typically be more resilient. And then finally, under social, these are really byproducts of or other co-benefits of decarbonization. That is that buildings that are healthier to their occupants, improve productivity, provide improvements to local air quality due to the elimination of on-site combustion. And then why should buildings be such a focus for decarbonisation? Well, really, when you break down the greenhouse gas emissions by sector, buildings are responsible for close to 40% of all emissions. And that figure's pretty common globally as well as within the US. So this chart is showing the breakdown of building breakdown for buildings between operational carbon emissions, the emissions associated with lighting, cooling, heating our buildings, and then a second figure that covers embodied carbon, so that carbon emissions associated with constructing buildings, refurbishing them, and deconstructing them at the end of their life. So you could say that energy efficiency codes and decarbonisation of infrastructure is trying to address the operational portion of this. We are starting to see new policies begin to address embodied carbon, as well as voluntary commitments that are starting to impact things like material supply chains. And in terms of zero carbon buildings, these focus areas were outlined by the New Buildings Institute as being pretty foundational to enabling zero carbon buildings. Energy efficiency is still seen as the highest priority due to its lowest cost to implement. So for new buildings, that's really driven by building codes, be those Title 24 in California or ASHRAE 90.1 in other parts of the world or other local codes. These continue to get updated, typically on a 3-year cycle, and continue to aggressively require increased levels of energy efficiency. And they've also started to now impact existing buildings that are undertaking major renovations as well. But additional mechanisms will probably be needed in California to help decarbonize existing assets. Enabling renewable energy is also critical, and that should recognize that some of these might be on-site, systems might be on-site, some might be off-site, as driven by the spatial constraints of a given building or given site. For off-site, that could include things like community solar, or arrangements with utility companies to develop a solar system for a specific entity, to offtake that solar. We've also seen code changes that are driving renewable energy, including a requirement that solar is provided now on residential buildings in California, and that non-residential buildings are designed to allow a solar system to be added or a renewable energy system to be added at a later date. So just allowing the infrastructure for that and the space for that. Building electrification is another key foundation. There are already policies in place to fully decarbonize the electric grid by 2045. Linked to this might be the need to design buildings so that they have future flexibility to be able to go fully electric in the future. So thinking about future electrical capacity needs and thinking about planning for things like future EV charging will be pretty fundamental with new construction. Embodied carbon is the next one, and we've just touched on that on the last slide, but we'll see that becoming a real focus in the coming years. One policy we have seen is the Buy Clean California Act, that's requiring state agencies in the state to construct buildings with maximum limits on the global warming potential for key materials, so such as structural steel and insulation. And then finally, we have building and grid integration, and this will really be required to address the overgeneration of solar energy from individual buildings. So currently that overgeneration during the peak hours of the day is exported to the grid, but there's actually no value to the grid in getting that energy at that time. Because the grid's also seen overgeneration from its own renewable assets at the same time. So thinking about ways that buildings can be more inert to the electricity grid through the use of demand response and energy storage, and perhaps by extension, how buildings can actually become an asset to the grid is again a pretty fundamental approach to decarbonization. So moving on now to some of the policy targets that are already out there. So these really start at the global level, set by the Paris Accord, which is moving us towards a climate neutral world by the middle of the century. And then we move down to the commitments that the US previously made for the Paris Accord, which will see us commit to limiting global warming to 2 degrees, preferably closer to 1.5 degrees compared to pre-industrial levels. So the goals on the screen in blue are those are the goals that were set previously by the Obama administration, and they will be updated by the current administration as part of rejoining the Paris Accord. And then on the next tier down, we have the state targets and state policies. So AB 32, which initially set California's commitment to decarbonization back in around 2006. And since that point, there's been additional bills that are now permitting the state to reduce emissions by 80% compared to 1990 levels. Additionally, there's SB 100, which requires utilities to push towards providing 100% fossil fuel-free electricity by 2045. And that's really driving the push towards electrification of our buildings and transportation systems. And then finally, we have the local policies, and these are taken from the City of LA's Green New Deal. So this is calling for all new buildings to be net zero carbon by 2030, and for the city to be carbon neutral by 2045. So a range of progressive policies in California, and I think the hope is that we're going to start seeing some similar ones be kind of drawn out by the federal government. So the next one I wanted to talk about was the subject of electrification, and this is really continuing the theme of local policies. So the trend of electrification, which is really substituting appliances and end uses normally served by natural gas with electricity. So we're seeing some cities now adopt what are called REACH codes. So these are policies that exceed the state energy codes, and they are leading to the limitation of natural gas usage, or the banning of natural gas completely at the city level. So this charge was really led by the city of Berkeley, which banned natural gas in new multifamily residential buildings. San Francisco has more recently banned natural gas in all city-owned buildings and all non-city-owned new construction. And then we've seen some cities limit natural gas use, so maybe allowing it for certain building types or end uses, such as maybe cooking. But other cities have a broader mixed energy policy, so you know, are pushing for increased energy efficiency, for example, you know, when allowing the use of natural gas. So in all, there's about 26 plus cities in California with some sort of natural gas limiting policy in place. And then the final one for me before I hand over to Zara, the other trend we're seeing in other parts of the world and are starting to see creep in here is a focus on decarbonization of natural gas networks. So Hide for Heat is one in the UK, that one current example of a program that's looking at appliances and in homes and their ability to burn different blends of hydrogen. The driver for this is that electrification currently makes sense in new construction from a cost perspective in many cases. It's a lot more challenging to implement electrification within existing buildings. So we've seen governments in Europe and Australasia start implementing pathways to decarbonize natural gas networks by blending hydrogen of differing amounts, and in some cases looking at fully replacing natural gas with hydrogen that's produced from curtailed energy, renewable energy, or where emissions from the production of the hydrogen are sequestered. We've also seen, you know, locally, SoCalGas go public recently with a hydrogen blending trial that will seek to blend renewable hydrogen within their existing network. So I think the takeaway here is that decarbonization is going to be a huge challenge that we're all going to have to wrestle with, and there's really going to need to be a broad suite of strategies on the table in order to get us to the point where we've really removed carbon from our lives. So with that, I'm gonna stop sharing and hand over to Zara to touch on embodied and operational carbon.
Thank you, Martin. If you could bear with us for a minute as I share my screen. Can you stop sharing, Martin?
Yep. Okay.
All right. Share screen. All right. Can everyone see my screen? Yep. All right. Okay. After understanding what decarbonization of the built environment means and going through some of the basic definitions and policies, I wanted to highlight the difference between embodied and operational carbon a bit more, with a larger focus on embodied, as most of us are more familiar with the latter. Until only recently, embodied carbon was a significant and largely ignored gap in the industry. It is gaining increasing attention, and it is now recognized that embodied carbon emissions make up to 20 to up to even 50% of the whole life carbon emissions of a new building. Embodied carbon, by definition, is the carbon emissions associated with the materials and construction processes throughout the whole life cycle of a building. In other words, it is a carbon footprint of all the materials and the products that go in a building. It considers how many greenhouse gases were released throughout the supply chain, and building elements such as foundations, frames, and other forms of superstructure often represent the biggest contributors to embodied carbon. Operational carbon is a term used to describe the emissions of carbon dioxide and other global warming gases during the in-use operation of a building. A typical building uses energy to meet heating, ventilation, cooling needs, and then the other uses such as lighting, cooking, plug loads, domestic hot water, they also consume energy. It's important to note, however, that operational carbon does not include water use. Recognizing that we don't have much time left to address climate change, we need to focus on strategies that can deliver the largest reductions in the shortest time. And reducing embodied carbon emissions, provides that opportunity because of the time value of carbon. Since most of these emissions happen even before the building operates, we need to consider not only the amount of savings, but the time frame of those savings to meet the emissions targets that are set out by Paris Accord. What does the term building whole life cycle mean? It begins with what you call the product stage. The product stage includes the emissions caused during the material extraction, transport to the manufacturing facility, and the manufacturing itself. Then comes the construction stage. The construction stage includes the transportation of these building materials or products to the construction site, the construction and the installation process itself. And both the product and the construction stages form part of what is called the upfront carbon emissions. Then the use stage begins. Once the building is constructed and occupied, this is when the building starts to operate. What is not part of operational carbon, although, is the maintenance, repair, refurbishment, and replacement, which is typically called the use stage embodied carbon. It basically includes the materials and the processes that were required for the upkeep of the built asset throughout the building life cycle. The next stage is the end of life stage, which is also the end of life carbon emitted during deconstruction, demolition, the transport to waste processing, and final disposal, which is what forms a typical building life cycle. The beyond the life cycle are the emission savings that are incurred or emissions avoided due to reuse, recovery, or recycling of materials. Life cycle assessment. Now, we can quantify material emissions and the environmental impacts of a building across the whole life cycle using a life cycle assessment, or LCA. System boundaries determine which processes are included or excluded in an LCA or an embodied carbon study, and are often differentiated by terms you must have heard, such as cradle to gate, cradle to grave. And what they mean basically is the measurement basically starts at cradle, which is the earth. Studies in which impacts are assessed only to the point where the product leaves the factory gate are called cradle to gate studies. Those which include all life cycle phases up to the point where the building is demolished and the materials disposed of as waste is cradle to grave. And if recovered and recycled, they're called cradle to cradle. It is generally recognized that studies should include cradle to cradle impacts when considering the whole life cycle. The results of an LCA of a product or a material are increasingly communicated in the form of environmental product declarations, or EPDs, which can be compared to the nutritional information that we find on the back of the products we consume. They are used by manufacturers to detail the performance of their materials, certify the carbon and environmental impacts of their products, and they are a very important data source for conducting the LCAs. The units in which operational and embodied carbon are measured are both measured in the units of kilogram of carbon dioxide equivalents per meter squared of the building. This value is calculated by multiplying the electricity and the gas that is consumed by the building with their respective source carbon conversion factors and then summing them up. EPA produces a list of these emission factors or source carbon conversion factors. The carbon conversion factor for electricity, for instance, also includes all the generation, transmission, and distribution losses. The embodied carbon of a building is simply the material quantity and multiplied by the embodied carbon coefficient. The embodied carbon coefficient is what factors in how the material is sourced, manufactured, transported, and all the emissions that have to do with that choice of material. So what is important is the material quantity, and material quantity is in the embodied carbon world is what EUI or energy use intensity is in the operational carbon world. So in essence, material efficiency is the new energy efficiency. There are various zero carbon and zero energy certifications available in the market. Each program takes a slightly different approach. They're all variations on a common theme, such as on-site combustion. Some of them allow, some don't allow any on-site combustion at all. There are different definitions or requirements for efficiency or whether off-site renewable energy is allowed or not. Unless the embodied carbon footprint is included in the definition of net zero, we're risking to neglect a large amount of the upfront carbon emissions, which is why many of the zero carbon certifications do list requirements for both embodied as well as efficiency requirements to reduce operational carbon. Moving on to strategies for embodied carbon, the following reduction strategies are applicable for new construction and renovation projects, which I will be diving into detail in the following slides. It is important to note, however, the best way to reduce embodied carbon is through prevention. By building nothing, we altogether eliminate the potential for embodied carbon emissions. However, when building, considering these reduction strategies from the outset, whether for a whole project or for a single product, is key. The first strategy is to reuse and repurpose. We should always question the need to use materials at all. Consider alternative strategies for delivering the desired function, such as increasing the utilization of existing assets through renovation or reuse. An example of such a repurposed building is the Spruce Goose Hangar in Playa Vista, the picture on the left. This was built in the 1940s to build the Spruce Goose airplane, but now, thanks to some innovative architectural and engineering innovations, it has been given a new lease of life as a creative office space. Using principles of circular economy, we should find ways to capture waste streams and reuse them or repurpose them for other things, perhaps outside of the process. The second strategy is twofold, really: build less and efficiently and build clever. Build less and efficiently basically means planning, designing, and constructing buildings so that they can be disassembled. Think about standardizing beam sizes and bay widths using bolted connections, prefabricated construction. This will not only increase efficiency of the installation process, but minimize waste on site as well. The second part of this strategy is to build clever, to plan for the future. Consider future scenarios and flexibility for future adaptation. The example over here is, for instance, when you're designing a parking structure to cover the future adaptability of other uses, addressing items like ceiling height or future elimination of parking ramps that could allow the structure to be adapted to an office, for instance. A study estimated that paying an initial 10% cost premium on such a flexible parking structure could lead up to 55% savings in cost when compared to constructing a new office building from scratch. And of course, the reductions in embodied carbon are obvious. The third strategy addresses one of the most important sources of material-related emissions in construction, and that is cement. Cement manufacture is responsible for around 7% of the global carbon emissions, with steel also contributing about the same, half of which can be attributed to buildings and construction. Both cement and steel require very high temperature during production, and in both cases, they have chemical reactions that take place during the manufacture that release carbon dioxide directly into the atmosphere. The growth of recycled secondary steel is encouraging to reduce the emissions from steel. However, the role of cement and other construction materials is crucial as we discuss the need of radical decarbonization. And what is gaining momentum is the introduction of low carbon concrete language and codes. And one such example is Marine County Code that puts a cap on how much cement can be used on projects and limits carbon emissions on concrete. This was funded by the Bay Area Air Quality Management District as a grant. The Buy Clean California Act is the first nation signed into the law that Martin mentioned earlier, and it targets embodied construction of carbon of construction materials, which will begin from July 1, 2021. The next strategy, as I mentioned earlier, material efficiency being the new efficiency in the embodied carbon world, it is important to specify lower carbon and healthy materials that go within the interior of the building in addition to the structure. Healthy materials have been around for a while. Low VOC paints, urea, formaldehyde, composite wood, they were in the early versions of LEED as well, and eventually were adopted by the state as code. We're seeing more and more transparency now around materials in terms of their ingredients, how harmful they are. And there are multiple material databases out there. Some of these products are self-certified, others are certified through a third party. A few of them are mentioned on the slide. And the trend will continue as the tracking of materials and products from a carbon perspective is getting more and more momentum. Also, this concept of biophilic design is continuing to see interest. It seeks to use approaches and materials that offer more opportunities to connect with nature, with the view that it can increase health and wellness within our built environments and increase productivity. An extension of the previous strategy, but specifying carbon sequestering materials is one way to reduce embodied carbon footprint. Carbon sequestering materials are materials that absorb carbon from the atmosphere during certain stages of their life cycle. Timber products and other biomaterials like bamboo and hemp present possibilities for capturing and storing carbon during growth. And compared to concrete, more and more timber construction is being seen in the market, particularly for smaller buildings. Using timber from certified sustainable sources where best practice forest management is applied is key. And of course, the reuse and recycling of timber should be promoted as well. There are many other examples of carbon smart materials as shown on the slide here. And many of these materials have ASTM ratings, tested R values, vapor permeance values, and whatnot, so that professionals and manufacturers can now specify, and we're seeing more and more of these being part of buildings. Moving on to operational carbon. Operational carbon strategies are somewhat of a familiar subject. These strategies are focused on reducing the emissions related to the operations of a building, applicable for both existing and new construction. And I will not dive into all of these strategies, but most of these have to be implemented before the building even begins operation, and during building initial design or during a renovation if the building is being retrofitted. They're typically implemented in the hierarchy of order shown to ensure an optimally designed building. The first 4 steps, load reduction, passive strategies, efficient systems, and energy recovery, form the basis of reduced energy consumption of your building. This reduced energy consumption is then offset by renewable energy generated on site. And the last step is offsetting the balance of the emissions, not covered through each of these other steps, through offsets, through the purchase of carbon offsets. Reducing building load through incorporation of passive strategies is key to ensure that the building's operational carbon footprint is minimum. As design of the buildings becomes more and more efficient, the plug loads, the lighting loads become a significant piece of the end use pie, as high as 33% for buildings like the Bullitt Center in Seattle. So installing LEDs, Energy Star products are obviously some of the strategies that could be used to reduce plug loads, other than very significant, very important ongoing monitoring and training of the building staff and users, so they're always tracking their building energy use. The next strategy is investing in efficient systems. By investing more upfront in the building envelope and other building passive design strategies, the reduction in building loads can lead to a smaller sized mechanical system to meet the heating and cooling needs of the building. And some of these mechanical systems listed on the screen, along with passive design strategies, can be used in line with the building electrification trend. Offsets should be used as a last resort to offset both residual embodied carbon and operational carbon emissions, either within the project or organization boundary that couldn't be reduced through the other strategies that we just discussed, including energy recovery and on-site renewables that I didn't dive into. Offsets are measured in tons of CO2 equivalent. Carbon offset programs let individuals and businesses offset their environmental footprint by paying to reduce greenhouse gas emissions elsewhere. It typically means that when someone is buying a carbon offset, the money goes to support new projects that reduce greenhouse gas emissions. Through these last few slides, I want to call the audience for action. How change in our sector will happen is through these 5 iterated set of actions, which is really an iterative process that needs to begin immediately. By enabling collaboration across the whole value chain between the supply and demand side actors, we can create an action roadmap to act on. We need to communicate our ambitions, our success stories, the research that we've done to build momentum and show evidence of what worked on our projects and what didn't. We need to educate all relevant members of the value chain. We need to raise awareness of embodied carbon and bring to life this life cycle thinking approach, and address foundational gaps in training and transparency. We need to innovate. We need to create new business models, new technologies, new methodologies, and circular patterns need to evolve. And lastly, through regulations, we need to mandate reductions in embodied carbon that can drive the innovation. And of course, this change has to happen through deep cross-sector collaboration with the identified key stakeholders on the slide, throughout the value chain that have a role to play in this approach to decarbonization. All forms of government can lead from the front by implementing ambitious embodied carbon reduction targets through policy and fiscal measures that can help enable the market. NGOs, networks, researchers, they together are catalysts for the radical whole value chain collaboration needed to drive market transformation. Research is crucial in developing new tools, technologies, methodologies or improving existing ones. And with the focus being on materials, the decarbonization of the manufacturing industry will require significant capital investment to create new resource efficient and circular business models. And manufacturers will only undertake these significant investments if there are clear demand signals coming from the designers, the clients, and the real estate investors. So the financial sector will also need to be engaged on both the supply and the demand sides to enable complete decarbonization. and not directly related to the construction and business, but many industry organizations and companies are also playing their part by setting out carbon neutrality standards for their operations in the years ahead. More and more campuses, university campuses, have incorporated carbon neutrality targets in their sustainability plans to align with Los Angeles goals. We need more voluntary leadership initiatives like the New York City's Mayor Carbon Challenge, which is a public-private partnership between the mayor's office and other, private and non-profit sectors. They have committed to reduce their greenhouse gas emissions by 30% or more over the next 10 years. And with 100 participants, it is estimated that about 1.5 million metric ton of CO2 equivalent emissions would be reduced. There are various platforms to engage in, no matter what role you have in the construction industry. On a local level, US Green Building Council, Living Future LA, and the Carbon Leadership Forum have a group dedicated to zero carbon. These groups are working towards implementation of widespread implementation of zero carbon buildings. And they're working, to help move the needle towards this decarbonization goal. So they encourage collaboration from all professionals from the construction industry. So please look to join. And on that note, thank you for your time today. And let us know if you have any questions. I believe there should be.
Thank you, Zara and Martin. Thank you so much for that overview. That was a great way to kick off this series. And there are a couple questions. I encourage people, if you do have questions, I'll start us out with one from the chat, but you can jump in and ask them, or you can send them to me and I will read them out. So let me jump into our first question. So we have a great question by our good friend Dave. Since it's still derived from methane, how effective is hydrogen as a decarbonization strategy?
I guess I'll take this one. Hey, Dave. Well, I can tell you from really just from our perspectives of what we're seeing on projects around the world, the direction these programs are heading is really for hydrogen, it's really a focus on a couple of strategies. One is obviously steam reformation, and obviously that uses natural gas to basically produce hydrogen. But it also creates pretty clean emissions that get captured. You can look to kind of sequester the carbon emissions from the process, and actually, some countries are looking at salt caverns to actually then store those that carbon. And then the other thing that we're seeing is a focus on electrolysis. So trying to look at using excess renewable energy to drive an electrolyzer and use that to produce hydrogen. So those are some of the things we're seeing around the world. In the UK, we're working on a project in Scotland, and that one in particular is looking at focusing on I want to say it's about a 600 home community, implementing electrolyzers, implementing storage, and those electrolyzers are actually powered from wind energy. So it's completely renewable hydrogen that's 100% hydrogen mix that goes basically into the homes and is then being used within homes for the regular uses that you would see within a home.
All right, fabulous. Thanks so much. We have another question. Can a contractor owned fleet that is all electric, such as a shuttle system, contribute towards LEED certification for a building?
I don't know if I am unmuted. I can take that one. I believe you can. So if you're looking at LEED zero carbon certification, that does account for the emissions that are related to the travel of the travel that the occupants do to and from the building site. So it at the end of the day, it all depends on the boundary that you're looking at and what certification you're talking about. So for LEED, yes, it should contribute.
I think the question applies also. They're wondering towards carbon neutral building. So yeah, it would be the same answer. Okay, great. So the next question and the final one from the chat is, one of our attendees is trying to get a developer to switch a structure from steel to wood. What is the best tool to help them quantify and explain the decarbonization benefits of that switch?
Yeah, I can take this one. And hi, Robert. I can certainly speak to one of our structural folks and send you some specific collateral. I would just say there's many studies out there that are comparing steel and wood structures. So including case studies. There are also some calculators out there, and there is one that out there called the EC3 tool, which is on the Building Transparency website, that might be worth checking out. And I think in addition to carbon, I think the other opportunity with timber that we are seeing more of is the opportunity to really start to showcase it within the building. You know, Zara shared the spruce goose hanger, right? And you can see the timber members exposed within that building, and it's really touching on aspects of biophilic design and connecting to nature. And I guess the other thing would be the other benefit would be the speed to construct with timber as well. So yeah, I think I can certainly follow up, Robert, and send you some specific collateral if that's of interest. And I guess there's lots of folks on the call as well. And in the spirit of collaboration, if anybody has other answers, feel free to ping them in the chat and or any other links.
Yes, I like that, in the spirit of collaboration. And is there any other questions anybody has before we wrap up part 1 in this series? All right, well, thank you both for presenting. Thank you, Ruby and the Decarb Committee, for putting on this series. You guys can stay tuned. We will be getting the date for parts 2 and 3 soon. So check back on the talent portal of the USGBCLA website to find out those. And we look forward to seeing you then. Thank you all so much and have a great day.
Right.
Thank
Thank
you.
you.